of you. Today I'll be taking one example in logistic regression, and I mean the same one which I had taken yesterday but in more detail, and also I will show you the implementation using the function also. Okay, so this is the program. So I'll do one by one step, and then I'll explain that step to you. So I'm making a vector, and the name of the vector is hours. Okay, I'm making that vector, so that is made. So it has got 21 items are there. You can see 21 items are there. I'm making another vector pass, and it has also got 21 items in that. So what is the meaning is that, so suppose there is 0 hours. One student has studied 0 hours means he will fail. 0.5, that's also fail. So like that we have got one pair of data. Okay, so it is telling, suppose we are taking 5.50 hours. If someone has studied, that student will pass. So what we are going to do is that we are going to make a logistic model, because it is categorical variable here. Pass is a categorical variable. It is either 0 or 1. So that's why it's called a categorical variable, and we are going to predict using this. We are going to make a model, and then we are going to predict whether that student will pass or fail with this hours. Okay, so we are going to make a data frame using hours and pass. Okay, so now we have made a data frame. So it has got 21 rows with 2 variables. Okay, now we are going to make a model. Okay, the equation for the, or this is the syntax for the model. For we have to give a formula and data and family. Okay, so I'm going to make a model, and I'm going to put that model in M. Okay, so now I made a model. Okay, so that model has come. So if you type summary, we'll get the details of the model we made. Okay, so we are good. So this is the result of the model. So when we call the summary, it tells the formula. So it is pass versus hours, and this is the residuals. And what are important is this is intercept and then hours. So I told you, as always, y equal to same what we did before, intercept plus one coefficient into hours. Okay, so pass equal to, so that will be the concept here. Coefficients are there. This is a coefficient for hours, and this is an intercept, and this is an error in calculating, and z value is got by dividing this by this. You will get the z value, and what we are more interested in the p value. So it is significant. 1 star is there, so it is somewhat significant. And about the null deviance and residual deviance, null deviance I have written here. Null deviance, so deviance is a measure of goodness of fit. So higher the number, it's always bad fit, and the null deviance shows the response variable when the intercept is alone there. Okay, and the other residual model is when one more independent variable is added. Okay, so what is shown here? So here null deviance means when the intercept alone is there, and this residual deviance is when one more independent variable is added. So how we can read it? How we can read this is 29.065 deviance on 20 degrees of freedom. Okay, so when we added this one more variable, then the deviance got reduced. So that is a good sign. Okay, so here 20 degrees means we have got 21, so minus 1. That's the degree of freedom here. The 19 came because we included one more variable, so and then 21 minus 2, that's how 19 came. Okay, degree of freedom is in this case is 19. Okay, so that's the explanation for the summary. So if your null deviance is really small, it means that the null model explains the data pretty well. Likewise with your residual deviance also. So now our residual deviance is good compared to the null deviance. So we have taken the pass. So it is good. When we included that also in the model, it is good. Okay, that's the meaning of that. And then now what we are going to do is that we are going to plot and see. Okay, plot, we are going to plot it. So what the main, this is just a plot of our hours and pass. What is here? Okay, so it is 0 and 1. Okay, now what we are going to do is that, so this is just to get the coefficient. There are two methods to get the coefficient, m dollar coefficient and or coefficient. We can use the function also. Okay, both ways you can get it. Okay, both ways. Okay, now what we are going to do is that we are going to get the probabilities using this equation. Yesterday I told you about this, p equal to e raised to y divided by 1 plus e raised to y. So using that formula, you are going to get the probabilities. So here y equal to, so you are substituting y here, y equal to intercept plus hours into coefficient. So coefficient, as we can see, the second item will be for the hours. That's why here the 2 came, and 1 will be, this will be intercept. Okay, so e raised to y, this is the y. Okay, this is our y. Okay, e raised to y plus divide by 1 plus e raised to y. Okay, again same thing. So you can see here, you're going to execute that command. So now probabilities has come in the variable PRED. Okay, you can just type this and see. So these are the probabilities. Okay, so probability values corresponding to our hours and pass. Okay, we use the coefficients in the model. Okay, and then direct p equal to e raised to y divided by 1 plus e raised to y. Using that formula, you got the probabilities. Now you are going to add these values to the graph, already plotted graph. Okay, so this is a sigmoidal model curve. Okay, and now just I tried substituting the values. 5.50 is the last item here, that 5.50. Okay, hours, and I check whether I am getting this 0.9857. Okay, just type, yeah, you got that. Okay, so just substitute and I check that. Now I'm going to make a data frame from the probability values. This one, this is the probability values we got. I'm going to make a data frame. I will show you why I'm using that. Now you can see what is in that. Same, I made a data frame with this column name. Okay, now I'm loading a library dplyr for using that. This is contained in that library. So what we are going to do is that we are checking this probability value. The probability values we are going to check one by one, and if it is greater than 0.5, okay, what is this is one line. What is going to do is that you are getting the data from this data frame. Okay, from this data frame you are getting, and it will check this PRED column, and if it is greater than 0.5, you will add, mutate means you are adding one more column with pass. So if it is less than or equal to 0.5, it will show you, it will write fail. Okay, that's it. So it is taking from the data frame, that it is taking from the data frame. That's why this symbol came. and then it will check whether PRED is greater than PRED, this column is greater than 0.5. If it is greater, it will write pass, otherwise it will write fail. Okay, let us execute this and see. Okay, now if you see what is contained in this, okay, we are going to, so see here, one more column is added to this. Okay, we execute this command we executed, and so one more column is added with PREDM underscore m, and then it tells if it is greater than 0.5, it will write, you can see here, it will write pass. Okay, because this is greater than 0.5, otherwise it will write fail. I hope it is clear to you. Okay, so that this is the thing. So I told you yesterday, I told you how that concept came. Okay, it is coming from basically log of p by 1 minus p. Okay, it is coming from that. Okay, this concept I will demonstrate by that also now. So this is, so I hope you understood, and this is just to, here you can see it comes zeros and ones. Okay, we type this just other way, one more type, it is printing 0 for fail, same thing what I explained to you before. If it is greater than 0.5, it will write 1. So now here I am going to use the formula log of p by one more method. So it is over till here. So now I am finding using log, and then I am checking whether it is a negative value or positive value. Actually, I told you log of 1 is 0. Okay, so if it is less than, log of less than 1 will give you negative, and log of greater than 1 will give you positive. Okay, so here say log of p, this is the concept I am using, log of p by 1 minus p. So here this PRED, what PRED is having, probability values. Okay, so I am taking PRED divided by 1 minus PRED. Okay, and I am taking the log, and I am storing that in one variable PRED underscore log. Okay, so now that is executed, you can see what is in that. So that's what, see, you can see here, this is less than 0.5. Okay, this value is less than 0.5, so corresponding to that you got a negative. So here it is greater than 0.5, so you got a positive value. Okay, so same thing, before we predicted, here if it is greater than 0.5, I wrote it is pass. So here I am going to calculate using the log and then see. So this log PRED underscore log has got some negative values and positive values. Okay, so negative values corresponds to all p values less than 0.5 and less than or equal to 0.5, and positive values means the p values greater than 0.5. So again I am going to make a data frame from that. So data frame will be same thing. Okay, data frame, I am making a data frame. So D was our, so what is D? D was our initial data frame. Okay, D is our initial data frame. To this I'm going to make a, I'm going to add one new column, and if this one PRED underscore log, so it had some negative and positive values. If it is greater than 0, it is positive, I'll write pass, otherwise I'll write fail. Okay, I'm adding a new column to D. Okay, so now you can see what is D. Okay, just see, I added one column. So here you can see what has happened here. See, actually we had 1 here, but we have predicted it as fail. Okay, so let us see that. So now here I'm going to make a confusion matrix. Okay, see here I had made a, for this I made a I made a vector that has got zeros and ones, and then I'm going to make a table with that. So actual, pass, and then predicted. So predicted is in this variable, and actually is in $pass. I'm going to make a tab. I'm going to make a table, and you can just plot this and see. See, this is the plot. So 0 and 0. So what is it? We can just see tab. Okay. So this is a confusion matrix, 0 and 0, where actually it was 0 and we predicted 0. That is 9. That's big. And only 2 items. Actually it was 0, but we predicted as pass. That is small. Okay. And 1, that is 8. That's also big. And actually it was pass and we predicted as fail. It is 2 numbers. Okay. So this is the confusion matrix, and then you can combine all the data frames, and you can see how it is coming. Just combining only. See, this is our initial hours and pass. I put D here in the center. That's where it came, and then you can see I added 1 column to that. That's why the predicted came. And then you can see this is using the log, and this is using the equation. So you can see whether when it is less than 0.5. See why it came. This was pass in the initial, but it came fail because the values, when we computed log, it is negative, and also p-value is less than 0.5. That's why the initial pass became fail in our model. Okay, this just I combined 2 data frames only. I discarded the initial one, so you can see. So now what I'm going to tell as a new topic is using the predict command. So what we did till now is we use the equation p equal to e raised to y by 1 plus e raised to y. So here I am using the equation. I am using the command predict. Okay, and I'm using my model. My model name is M. Data frame is D, and type is response for the probability. For getting the probability, and I'm just executing this command. Okay, so let us see what is in the predict underscore com. Predict underscore by command. See, and then just I'm typing predict. See, both are same. You can see here. Predict and predict by command. This value you can see here. So we are getting the same by equation and by using the command, predict command. So I'm just using this again to get the log. Okay, I'm using that log of p by 1 minus p. I'm using that, and then you can see what is in that. It will have some negative values and positive values. Okay, same like we got before. Okay, we got where we got here. You can just check. See, both are same. Okay, you can see here both are same. Initial one is minus. See here, this 2, and last also you can check same. Now what I'm going to do is I'm going to add one more line to our initial one, predicted by command. Okay, I'm adding, and now you can see what is in the D. Both will be same. These 2 I mean predicted and predicted underscore command both will be same. Okay, so this is how you get the logistic regression by equation and command. Hope you understood. If any doubt, you can just comment or you can mail me. I'll reply to you. I hope you understood. I'll just recap once again what we had done till now. So we made two vectors here, and then we made a data frame from that vectors, and then we made a model, logistic regression model using the command glm, and we saw the summary of that model, and then we plotted the graph and we plotted the probabilities also. Okay, probabilities. So it is going from 0 to 1, the probability. And then what we did, we used the equation and we predicted the probabilities. Okay, using the equation, we got the probabilities. And then this is for just cross checking, and then important ones only I'm telling. And then we found which all probabilities are greater than 0.5 and less than or equal to 0.5, and we stored it as 1 and 0. And this I used the log model, log of p by 1 minus p. So it will be negative if it is less than 0.5, it will be positive if it is greater than 0.5. And that's all the main important thing. And here I made the confusion matrix, and here I used the predict command and proved both are same using the predict function and also the equation. So what are using this predict command and then our equation, this one. Okay, both are same. You are getting the same value in PRED and PR predict by command, both same values. I showed here predict by command and PRED both have same values. Okay, I hope it is clear to you. Thank you very much.